Hey guys, Travis Gillespie here. Here's another table to look at, and we're going to write an expression for the sequence in this table. So let's start with the value and ask ourselves, can we find a pattern from, in this case, 7 to 10? And then after that, from 10 to 13. Alright, so let's see here. How did I get from 7 to 10? Well, it looks like I'm adding 3. So I'm adding 3, and how did I get from 10 to 13? Well, it looks like I'm adding 3 again. Cool. So it looks like the change or the difference between values is a change of positive 3. So I'm going to take this value 3 and I'm going to draw an arrow all the way to the first term here. Before I do that, let's just change colors real quick. Alright, so my arrow, I'm going to take this positive 3 here and I'm going to draw an arrow all the way over to the first term. Now you don't need to do this once you get comfortable with it. It's just to give you a visual of what I'm doing. So I'm taking positive 3, I'm going to carry it all the way over to the first term, and I'm going to multiply the value 3 times 1 here. So 3 times 1 will give me a value of 3. So how do I get from 3 all the way to 7? Well, I've got to add 4. Add 4. So my expression, well, it looks like it's 3 times 1 plus 4. Let's carry this arrow over to the next cell. Alright, or the second term here. So how do I'm going to take 3 and I'm going to multiply by 2. So 3 times 2, and 3 times 2, that will give me a value of 6. So how do I get from 6 to 10? I've got to add 4. So let's add 4 to this expression. Now let's move on to the next term. Okay, so moving on to the next term, so I'm going to take 3, I'm going to multiply it by 3 in this case, so 3 times 3, so 3 times 3, that gives a value of 9, and to get from 9 to 13, again I'm going to add 4, so add 4 to the expression. Alright, so let's move on to the last term. And all this last term, the term n, is saying is, if you were to substitute a number n for n, what would be the resulting value after you run through the expression? So let's write the expression. I'm going to start with 3, I'm going to multiply it by, now don't trick yourself, don't fool yourself and say this next value is 4. We're going to take 3 and multiply it by n, so 3 times n. And whatever value 3 times n gives me, whatever value this is, well, from our past experience, we've added 4 to get to the resulting value. We're gonna add 4 again here, so we're gonna add 4. So let's clean this information up. So I'm gonna add 4 up here to this expression, but I want to clean all of this up, and I'm gonna choose a new pen color. Okay, so my expression, it's 3 times n plus 4. I'm going to clean this up and rewrite it below. So I'm going to start with 3. I'm going to multiply it by n, but I don't need the multiplication symbol in between 3 in the variable. And then all I have to do is add 4, so plus 4. Cool, so your last step, if you wanted to make sure your expression holds true, you would check your work. You would substitute a value in for the variable n, and then evaluate the expression. But then you'd soon find out that you'd be able to build expressions all day long when working with arithmetic sequences. Cool stuff, guys. I'll see you in another video.